Hello, let's continue our Sudoku adventure with Space Needle by MicroStudy. So I do believe this is the hardest puzzle and also last puzzle of our Doublers theme week. So don't worry if this takes you a little bit longer than usual or a lot longer than usual. And you can always refer to my video if you get stuck. All right, so this is Doublers with skyscrapers. If you know what that means, go on ahead and try the puzzle. If not, I'm going to go over the rules in detail. So we have normal 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. There are also exactly 6 doublers in the grid, with each number doubled exactly once. So what does that mean? It means that every row, every column, and every box has one doubler. Doublers can't repeat in rows, columns, boxes. We need one per row, column, box. So if I have a doubler here, then the rest of the column, the rest of the row, and the rest of the box may not be a doubler. I'll use gray to denote that. Also, let's say we put a 2 in that doubler. It means that we can't have another doubler with a 2 in it, no matter where it is. We only have 6 doublers, and we need each digit to be doubled once. So we could put a 1 there, for example, but not the 2. All right. Additionally, the value of a doubler cell is doubled. So normally the value of a cell is just the digit that's in it. So this would have a value of 3. But the value of this cell is 4 because we have to double the 2. If this was a 4, we double it, it would have a value of 8. For the purposes of skyscrapers only, not for Sudoku. I can't repeat the 4 in the column, even though this one's doubled. That Sudoku doesn't care about that. All right, so also we have skyscrapers. I'll go over skyscrapers without doublers first, just so I can explain them, and then I'll explain how doublers affect that. So with skyscrapers, imagine that you're standing where the clue is, looking in this direction, and you're counting how many skyscrapers you see. Each cell has a skyscraper in it, and the height of that skyscraper is the value of the cell. So if this was 2, 4, 3, 6, 1, 5, for example, then when we're standing here, we always see the skyscraper in front of us. So we see this too. Let's use purples because green I'm using for doublers. So you see this too. And then the 2 blocks any skyscraper that is shorter than it or the same height as it. So we would not see this 1. Let's use red for what we don't see. We do see the 4. So now that we see the 4, this 3 gets blocked. Then we see the 6. Once we see the 6, the 5 gets blocked. So now we count how many skyscrapers we see. We see 3 of them, and that matches the clue. So this would be one way to fill this clue if we did not have doublers. However, we do have doublers. So let's say this 3 got doubled. Well, this clue would still be valid because we'd see the 2, we'd see the 4, and then this is doubled in height, so it's a 6. And the 6 blocks the other 6. It has to be taller in order to see it. So it blocks the 6, 1, and 5. And this would be a valid skyscraper. But if I double the 4, that's of height 8. It's going to block all of these. We'd only see 2. So that's skyscrapers, and that's how it interacts with doublers. Hope that's understandable. There's a link in the description if you want to try the puzzle yourself. And I'm going to get started right now. Okay, I think maybe the place to start is this top row, because normally you can't have 1s across from each other with skyscrapers. The reason for that is traditionally a 1 would need a 6 next to it because you need to block everything after it. You always see the first 1, right? So if I saw the 5, there's going to be a 6 somewhere in this row. And so I'd see 2. But these can't both be 6. So one of them is 6 and one of them's a doubler. So we can already mark these as not doubler. So what can we double though? If we double something too small, like a 1 or a 2, like if we doubled the 2 here, and this would be the 6, we'd actually still see the 6. We'd also see the 5. So we can't double a 2. Doubling a 3, that would work actually because the 6, the doubled height 3 of 6, this 6 skyscraper blocks this one, is what I'm trying to say. And this one blocks this one, so that would work. If this was taller, oh, interesting. It works for this clue, but it doesn't work for this clue because we'd still see it. So actually, what we have concluded here is that this is a 3-6 pair, and the 3 is doubled. But this too, I guess I should point out that there's only one double. There's exactly one doubler for each skyscraper clue, right? Because every row and every column has exactly one doubler. I think I was implying that, but I never actually outright said it. So hopefully that's clear. If this was a 3, the doubled 3, I can't have another doubler below it, so I wouldn't see anything else. This would have to be a 1 clue. So actually, this is the 6, this is the 3, this is the doubler. We can mark all of these as not doubled. We get our first digit and our first doubler. Nice. So now we need a doubler down here, and it needs to be a 4, 5, or 6 to be taller than the 6. But we don't know where it goes. There's definitely a doubler in here somewhere. I don't know if I should mark that. I don't think that's helpful. This will just finish itself. Okay. 6 is the other extreme. So let's just say that if there were no doublers in the row, a 6 would have to be 1, 2, 3, 4, 5, 4, 5, 6. But it can't be. And there is a doubler in the row. So we actually have to put the 6 earlier, which means the last cell has to be a doubled 4 or 5, actually, because it can't be a 6. And then we have to go in order. So we're going to go 1, 2, 3 for sure. And then this still can't be the 6, because if this was the 6, I'd be obscuring the 4 or 5 behind it. So this is the 6, and then this is a 4 or 5. And actually, these could be either. This is still a pair. But we did get this doubler, so we can mark all of this as not doubled. There's a doubler in here. This is 4, 5, 6. This is 1, 2, 3. And that actually fulfills this 2 clue as well. Right, so the 2 clue disambiguated the 3, 6, but it wasn't really used to find the... That's fine. I was just trying to figure out what the 2 clue is for, but there we go. These are both 3s, and there's a doubler in here. I don't think this can be a doubler, because if this is a doubled 4, 5, 6, it's the last thing we're seeing. So we only see 2 cells. So this is the doubled 4, 5, 6. Can we double a 6 here? I don't see why not. We double a 4 here? I don't see why not. Yeah. These just have to go... This can't be a 6, though. If this was a 6, we'd only see the doubler. So that's not a 6. And this is not a 4, because if this is a 4, it's blocked by the 5. So that's not a 4. Yeah, these kind of... If we wanted to, we could just sort of draw a little thermo there. Maybe I'll use like gray or something. Green is too much. Here, we'll draw a thermo there. So these are increasing. Is it the 3 and 3 here now? Oh, these also have to... Wait. No, these shouldn't fully increase. So we can't just draw a thermo here, where we'd see all 4 of them. So does that mean something about restrictions? I'm not sure. Well, this can't be a 3, because it blocked both of these. So it's a 1 or a 2 only. I think 2 works, though, because we can block the 1. But if it's a 1, we just need to put the 3 here. Oh, but this can't be a 2, because if this was a 2, this would be 1 and 3, and that would be in order. So that's not a 2. Is that the same for this? Can this not be... Let's see, if this was a 3 or a 2, let's see. It feels like pattern-wise we'd remove the 2 from here. But no, 2 works fine. This would be 1 and 3. Okay, maybe the pattern, maybe it's not a pattern at all. It's actually similar to this, isn't it? But a little different. I don't know. What am I rambling about? Let's move on. Let's do this puzzle. There's a 6 down here. Can this be a 6? I think so. We'd still be able to see 4, as long as we double something big over here. Oh, I didn't fill this doubler. Or gray out these doubler. Let's make sure we stay on top of that. Maybe it is these 3s. All right, we know there's a doubler down here. One of these 2 is a doubler. Let's mark that. Also, one of them is a 3. Okay, and I can tell you that the 3 is not the doubled value. Because if we double a 3 in either place, that's going to block the whole rest of the column. And we need to be able to see something up here in order to get to 3. So, oh, and so we're definitely not doubling a 4, 5, 6 either. So we have a 3 that's not doubled, along with a doubled 1 or 2. Oh, but not the 2. So this is just a 1, 3 pair, and the 1 is doubled. So instead of corner marking the 3, I'm going to corner mark the 1 to represent that we have a doubled 1 there. Now this can't be 6, because if this was 6, then I can't see this doubler, right? So I'd only see these 3. So that's the 6, and I don't know if it's doubled or not. I was going to mark it I don't know why I was going to mark it not a doubler. This is not big enough to be seen. There's going to be at least a 4 over here. None of these are 6. So there's a 6 over here. Oopsie. Is there more to Sudoku or something here? Well, we got this 1, 3 pair. So these are 4, 5, 6. That's not a 6. So let's think about this 3 then. Because basically it's just a straight up 3 skyscraper. We're not going to see the doubled 1 down here. The 2 blocks it. In fact, we're not going to see the 2. I think we just have to see these in order. I think this has to be a 6. Yeah, this certainly can't be a 6. Yeah, I think these just have to be 4, 5, 6. I think that's the only way we're seeing all 3. Okay. That's neat. We need a 1, 2, and 6 here. I'm just going to fill that and clean it up a little bit. So what did this do? Well, we have a 4, 5 pair in doublers now. We have to double a 6. And look, this is the only 6 that can be doubled, so this is a doubler. Look, this 6 can't be doubled, this one, this one, this one, and this one. None of those can be doubled. It's 1, 2, 3, 4, 5, yeah. This is the only doubled 6. Rest of this box, rest of this column. And also, this one is not doubled, so that's the 3. This is the doubled 1. And hopefully, yes, okay. I probably could have figured that out from the 3 skyscraper as well, because the 6 was the end of it. So these had to go in order. This was neat, though. Okay, so what's that tell us? That tells us this is a doubler, and it's the last one. It's a 2. Places that 2, 6, and 1. Okay, that places that 6. This is 4, 5. These are 2, 4, 5 with the 2 there. All right, this 4 skyscraper, now that this is a 6 and the doubled one's after it, these have to go in order. So we can draw another thermo. We can draw it all the way there if we want. So 6, 5, 4, 3. So 1, 2. Oh, this is not a 1 though. So that's how we'd fill that thermo. So is there a question to ask here? I need a 1 over here. Maybe I'll just pencil these. So I need a 3 and a 4 here, and I need a 1 and a 5 here. Oh, no, sorry. I thought I saw a 3, 4 pair, but I was scanning wrong. There's a 4, 5 pair though. So that's a 3, that's a 4. That's 5. This now has to be a 4 because of the non-repeat rule. That's a 5. These are not 5s. This thermo did it correct. Good. There's a 4 there. There's a 5 there. That's not a 3. This is 1 and 5. 2, 1, and 3. That's a 1. We get the 4, the 2, and the 4. That's a 3. That's a 2. And suddenly we're done. Wow, okay. Yeah, 940 feels about right for this puzzle. Quite intricate. Definitely. Honestly, it at least for me, it always felt like I knew which skyscraper or set of skyscrapers to look at next. So that was neat. I wonder how restricted this 6 was. Like, was it always going to have a doubler at the end? I think it had to have the doubler at the end. But that doubler could have been a 6. But still, I think this 6 automatically puts a doubler right here. I don't think there's any other way to do it. Because if you double a 1, 2, or 3, the 6 before it's going to block it. Or it'll block the 6 if it's a 3. That's interesting, yeah. And then 4, 5, or 6 will be bigger than the 6, so it needs to be last. And then the rest go in order. That's cool. And so that does immediately resolve this 3, 6 pair. This 3, 6 pair was neat as well. I liked that idea a lot. Yeah, flowed pretty nicely. Very intricate. I can see why this was marked as probably the most difficult of the week. That's why I put it last. Hope you enjoyed it. And if you did, then why not leave a like, subscribe, and a kind comment below.